Hello and welcome to our video game titled The Battle of the Marauders. This is a unique RPG where players of this video game have been teleported into the video game itself and must battle through various enemies and travel through treacherous terrain to escape this fantasy world. As a brief overview, players start by going through some initial menus. These menus tell them about the game rules, the story, and allow them to choose a character, in which they can choose between three different protagonists, a wizard, a warrior, or an archer. After this, their adventure begins. This unique RPG has two styles of gameplay that it alternates between. The first is a 2D platforming segment where the character controls the sprite with arrow keys and a spacebar, and they have to jump between the platforms to get to the end of the level, signified by a floating sword. Upon touching the floating sword, they are awarded a set amount of 20 points and then start a 2D turn-based combat system operated using the left click of their mouse, where they battle enemies and are awarded points based on the amount of damage they deal and the amount of health they have remaining. There are 7 different levels to the game, each with its own platforming and combat segment. With each level, they earn points, battle cool enemies, and explore beautiful environments. During the midpoint in the game, they are also able to visit a shop and make a strategic decision to upgrade their power or health. We will now be going through the distinct sections of the game and describing some of the logic and code. So now I'll be walking you through the battle system implementation, represented by the various battlesystem.py files in our repository, and each of these files correspond to a battle with a specific enemy. The game contains 7 different enemies that the player can encounter as they progress through levels such as goblins, skeletons, and sorcerers. And the battle system actually features turn-based combat, which you see in the gameplay on screen. In a turn-based combat system, the player has to strategically choose which of the enemies to attack in order to save themselves from receiving excessive damage. It's turn-based because once the player chooses which enemy to attack by hovering their cursor over the character sprite and doing a left click, the enemies will each have a turn to attack you as well. The goal of the battle system is to defeat all the enemies on screen. The battle system also features a bottom panel to display the players' and enemies' health points and track the player's score thus far. I'll be now walking you through chronologically the code for the battle system and going over some parts that are a little bit more complicated in more detail. So the first section is just imports and initialization, and here we'll be importing some required modules like Pygame, OS, and Random, and we also import the function for the following platforming level of the game, which is loaded in if the player successfully wins the battle. The next part of the code is the primary function called battle system page, and this sets up the game environment, including characters and user interface elements. And this function takes parameters like the name of the character, such as wizard, archer, or knight, and this specification allows us to load in the correct sprite animations for that character. It also takes a parameter for the number of points the player has accumulated thus far into the game. Other parameter the function can take depends on the battle, such as the current power of the character, which incrementally increases, or the health, which is upgraded by the player's choice later on in the game. We also will initialize various game variables like clock, FPS, and game state flags, which allow the script to control the turn-based combat. And the game loop actually iterates through each frame based on these variables and flags. For example, the current character variable is used to determine which character's turn it is and to execute their actions, or for instance the endgame signal variable, which is used to show the appropriate end screen, victory or defeat, and manage the game's progression and termination. Next, there is a colors and fonts section where the colors and fonts for the game are defined. Then there's a draw text function to render the text on the screen at specified positions. Then various images assets will be loaded in using pygame.image.load for things like the background, the panel image, and character-specific pointer images. And then there are functions for draw background, draw panel, and these are used to draw both the background and user interface panel respectively. Then the main class of the game is the character class, and this class initializes a character with a position using X and Y coordinates, a name, a max health value, a power, scale, and points variables as well. And this also keeps track of the character's health, alive status, and it also has an action variable which represents 0 for idle, 1 for attack, 2 for hurt, and 3 for death. And the character's animations are loaded in from folders as well in this class. And these folders contain images for each animation state for idle, attack, hurt, and death. And the class counts the number of images in each folder using the OS module and loads them into separate lists, and then each list is then animated to an animation list, which stores all the animation states for that character. Then there's also an update method, which is handling the character's animations and uses an animation cooldown variable to control the speed of the animations. And when an attack happens, the attack method in this class is called, and this deals damage to the opponent based on the character's power and also a random number value. And then the opponent's health is reduced by the calculated damage, and the opponent's hurt method is called. And if the opponent's health drops below 1, their alive attribute is set to false, and the death method is called. There's also a points change method used to change the character's points, and there's also a hurt and death method that both set the character's action and reset the frames. Finally, the draw method uses the blip function to draw the character on screen using the current frame from the animation list. Then we have some other classes like health bar and visible. Health bar class represents the health bars displayed on screen and draws them with the appropriate colors and sizes. And the invisible class helps draw some invisible rectangles where the enemy characters are placed. These rectangles are used to detect when the mouse clicks on enemies during a player's turn. There's also a damage values class, which uses the pygame.sprite.sprite, and is used to display some damage values on screen that animate upwards by changing the sprite's self.y property, and then they eventually disappear. And then after all these classes, we finally instantiate some variables. So we instantiate the character class for the player's character and 2 enemy characters. And here we can determine things like how much health and power the enemies and the player have, and this helps us modify the difficulty of the game for each level. And then the health bars are also instantiated as well using the health bar class. Then in the main game loop, it's controlled by the running variable, which is where the game's logic and rendering take place, and the loop continuously updates the game state, handles user input, and renders the game components to the screen. And during each iteration, the background panel are drawn, character and health bar updates are performed, and user input is processed. And actions like attacking are taken based on the user's input and the current game state. This game loop also handles endgame scenarios like victory or defeat by displaying appropriate messages and upgrading the game state accordingly. The victory and game over banners are displayed for a set period of time using a counter variable that incrementally updates, and then the next platforming level is called if the game state indicates that the player has successfully won the game. And there you go, that's a brief overview of the battle system.
Now we'll be talking about the character selection of the game. In this window, the player can choose between 3 different characters, an archer, a knight, and a wizard. The code consists of several functions that handle different aspects of the character selection process, such as rendering text, displaying character images, and handling user input. The second page function is the main function that sets up the character selection screen. It initializes colors, loads images, sets up text rendering, and calculates positions for the images and text elements. This function also contains the main game loop that updates the screen and handles user input. The game loop consists of 3 parts: an event loop, game logic, and rendering. The show character function takes the character string, a wizard, archer, or knight as its argument and returns a text surface object rendered in the appropriate color for the given character: blue for wizard, green for archer, and dark gray for knight. The print character function takes the character string as its argument and displays a message on the screen indicating which character has been selected. It first clears the area where the text will be displayed, then renders and displays the character name in the appropriate color, along with the message saying has been selected. It also displays the next and quit buttons. In the event loop, the code checks for various events, such as a user closing the window or clicking the mouse. If the user closes the window, the game loop ends, and if the program exits. If a mouse is clicked and detected, the code checks whether the click was on one of the character images, the next button, or the quit button. If a character image is clicked, the corresponding character is set as the selected character for the game, and the print character function is called to display the section message. The game logic section of the main game loop checks the position of the mouse cursor and determines whether it is hovering over any of the character images. If the cursor is hovering over a character image, the show character function is called to display the character's name below the image. If the cursor moves away from the character image, the code clears the area where the name was displayed and redraws the character image without the name. In the rendering section, the code calls pygame.display.flip to update the screen, refreshing the display with any changes made in the game logic. This is followed by a time.sleep of 0.05 call, which slows down the loop slightly, ensuring a smoother experience for the user. Overall, in the game loop, the code continuously checks for user input, updates the character selection screen based on the user's actions, such as hovering over a character image or selecting a character, and refreshes the display to show these changes. When the user clicks on the next button, the controls function from the imported controls module is called to proceed to the next part of the game. If the user clicks on the quit button, the game loop ends and the program exits. In summary, the code sets up a character selection screen where the players can choose between three different characters, Archer, Knight, and Wizard, by clicking on their images. The code handles user input and updates the screen accordingly, displaying the selected character and options to either proceed to the next stage of the game or quit. The upgrade system operates in a similar manner, whereby the upgrade page features two distinct images, one for health and one for power. Clicking on the power icon grants the player additional strength, while selecting the health icon provides supplementary health. It is important to note that the player must make a decision between these two options. Once the selection is made, the upgrade is implemented and remains visible throughout the subsequent battle stages. Let's now shift our focus to the platform sections of the game. It's worth noting that the code has been slightly modified for the remaining platform levels. There are multiple functions and classes defined in the platform levels. The flip function flips the given sprites horizontally, and the load sprite sheets function loads the sprite sheets from the specific directories, handling both the left and right directions if needed. The get block function retrieves the terrain blocks, while the set level character function sets the player character based on the user's choice. During the platform levels, the character is transformed from the battle system to the platform in order to identify which character is being used. This is done by the various set level character functions, or just passing in when the battle system function is called. The main character is the game in the game is represented by the player class, which inherits from the pygames .sprite. This class initializes the player's attributes, including color, gravity, sprite animations, and other properties. The player class has various methods for handling movement, such as jump, move left, move right, and loop, as well as methods for managing sprite animations. Two other classes, object and block, are used to create various game elements. The object class inherits from the pygame.sprite and serves as the base class for the other objects, while the block class inherits from object and represents the terrain blocks in the game. Additionally, there is a sword class for creating the sword object that the player can interact with. Once the player collides with the sword object, the next battle system is initialized. The get background function loads the game background image and returns the necessary tiles for rendering the background. The draw function handles the actual rendering of the game elements on the screen. The handle vertical collision and collide functions manage collisions between the player and other game objects. The handle move function processes the player's movement based on keyboard input. The main function serves as a main game loop. It initializes the game objects, background, and player, then continually updates the game state, processes player input, and renders the game elements on the screen, such as the blocks to create different platforms. The game loop continues running until the player reaches the end of the screen, or the game is terminated by the user. In summary, this code implements a simple 2D side-scroller platform using Pygame, with a customizable player character and various interactive objects. The code is organized into several functions and classes to handle sprite loading, game object creation, collision detection, and rendering. The game loop in the main function manages the overall game state and user input. So once the character collides with the sword object, the game ends. Thanks for joining us on this journey into the creation of our Python game. We hope you enjoyed the video presentation that gave you a behind-the-scenes look at how we developed the game. It was an exciting challenge, but we are proud of the final project, and we hope that you enjoyed playing it as much as we enjoyed creating it. Thank you.